Let's start this session with a thought. Have you ever noticed how our brain works when we wake up in the morning? The first thing it does is ask a question. What should I do next? It might be brushing your teeth or checking your phone or making tea. But the mind needs an instruction. And that's how we stay organized step by step. Now imagine the CPU, like we call it as heart of every computer. It's not very different from us. It also works step by step. It also asks the same question, what should I do next? That's exactly what happens in the fetch stage of instruction cycle. Think of a CPU as a very disciplined silent worker. It never gets tired. It never complains, but it always needs something called as clarity. It can't start doing something randomly. It first needs to know what to do. And that's where the fetch stage comes into picture. It's the moment the CPU goes to the memory and picks up the next instruction to execute. And this is the CPU's first step, that is the moment of awareness. Like a person checking their to-do list in the morning. Let's make it simpler with a story. Imagine you are in a kitchen and you are about to cook your favorite dish, let's say pasta. You open the recipe book, the book that you opened, think of it as your main memory, RAM. It has all instructions written step by step. Now your finger you are using to point to the next line of the recipe is your program counter. It knows exactly which step to follow next. You read that line carefully. Say for example, it says boil water. But instead of staring at the book all the time, you note it down on a sticky note and you keep it near you. And that sticky note is your instruction register. It holds the current step you are working upon. Once you finish the step, you move your finger to the next line. That means ultimately you increased your program counter and you keep the above process repeated as in a cycle. So you see, the CPU just works like us. It has the place where all instructions are stored, that is memory. It has a pointer that tracks what's next, your instruction pointer or a program counter, and a little box inside where the current instruction lives, that is instruction register. Without these three working in harmony, the CPU would be confused. Just like we would lost in a recipe. If we forgot which step we are on. The simple process of fetching is what keeps the computer alive and logical. Now let's bring this idea to life using a short C program, which I already wrote. This small program will simulate the fetch stage. You will see how the CPU fetches each instruction from the memory, puts it inside a instruction register IR, and then moves forward. Now let us open the code which I have written. What I did here is I included two header files, stdio.h and string.h, because I am going to make use of some string functions here. Then, as usual, integer main. I'm declaring here a character string array or a string array, which I gave or named as memory. It contains say 4 instructions, say load, add, store, and halt. Then I am having a program counter, which is initialized to 0. Then I am having an instruction register like size 50. Then I'm having a printf statement, CPU fetch stage simulation. Then initially I am printing what is the value of program counter through the memory. That program counter is pointing to memory with PC value. So memory array would be referred with the PC value. First location, second location, third location, and so on. I'm copying contents of memory to instruction register. Then I'm showing which instruction actually I fetched through memory PC. Then I'm printing what is the value of IR, what are the string that got copied. Then I'm increasing the program counter. I'm pointing to next line now. Then I'm checking if my last instruction, like when I'm like in above array, I have my last instruction as stop. So I'm comparing if instruction register contains that stop instruction, then it should terminate. So I'm saying stop found, CPU is taking rest now, and then break the loop because I have used while one. And then ultimately, like if it doesn't hold, then printf and continue to next line. That's how the code is working. And lastly, I'm returning 0 and nothing. Like what? Let us walk through what this program is doing. Not as a code, but as the same story which I earlier talked about. Memory, which is an array like your recipe book, it holds all instructions. Here, like as an sample case, I have taken 4: load, add, store, stop. My program counter, it starts at 0, pointing to the first instruction. Now the CPU is looking at memory 0 at the initial stage. Fetch or fetching next stage. Let the CPU reads the instruction from memory 0, copies that into IR using strcpy, which we used here. Correct. Then further, that's like taking the current recipe step and writing it on a sticky note. Once the instruction is inside IR through strcpy, the CPU holds onto it tightly. That's its focus for the time or for that moment. If we print instruction register, we will actually see what the CPU is currently working upon. Then we are incrementing the program counter because the CPU moves its program counter to next line or forward by 1. It is ready now for the next instruction, keeping the flow continuous. And when the CPU finally fetches stop, it knows its job is done. Then we wrote like stop found. CPU is taking rest. If you see, there is no confusion, no stress. Let us execute this code. Compile and execute this code. So GCC page.c. Fine. Now let us execute. Now you can see here. It's like watching the tiny mind thinking, reading, remembering, and moving on. Like for example, we started with PC to be 0, PC pointing to memory 0. Fetch instruction is first instruction which we wrote in the code. Now we copied it into instruction register. So instruction register now contains load AS. Then we increment, we checked whether instruction register, what are the instruction that we fetched, whether it is stop, like we compared with IR, the stop instruction. So it is not. So that's why program counter would be pointing to next memory now. Program counter is pointing to memory 1, reading the next instruction, paste it. Then instruction register, the string gets copied. Then like automatically your program counter will be increasing. Now you are checking instruction register again, whether it is stop, it is not. So now again loop continues. Now it is pointing to memory 2, fetch the instruction, that is store A100. Instruction register copies that, like that instruction from the code memory would be copied to instruction register. Now it contains store A100. Increments program counter, checks whether IR is stop, it is not. So now PC is pointing to memory 3, loop continues. Again, fetch the next instruction, stop. Instruction register will be getting copied that instruction from memory. Now it is having stop. Increment the program counter becomes 4. But we see like stop is found in IR. And then we said loop break. Then CPU is taking rest. It is, as I stated, it is like watching this tiny mind thinking, like reading, remembering, and moving on. This is more than a program. It is actually mirror of how real processes work. 3 important things. This program counter shows focus. It tells the CPU where to look next. IR instruction register shows memory. It holds the current instruction safely. The CPU shows the discipline. It does one thing at a time perfectly. And when the CPU reaches to stop, it's not crashing. Please understand. It's peacefully saying, I have done everything you asked me to do. Now think about this. The CPU handles millions of such instructions every second, but it never gets panic. It never says, like for example, oh no, I have too much to do. It just fetches one instruction, focuses on it, finishes it, and moves on. And it is not that how we should handle the life too. One instruction, one task, one moment at a time. So the fetch stage may sound like a small technical term, but it actually teaches us something big: clarity, focus, and calmness. Just like the CPU, if we always know what's next, if we stay focused on one step at a time, and if we take rest when the task is done, we will never lose our rhythm. The CPU's phase process is not just logic, please understand. It's a life lesson in disciplines and patience. So when you write code or build systems in the future, don't just think of machines as lifeless. There's an order, there's an intelligence, even the emotion inside those little cycles. Like today, we talked about fetch. Next session, we'll be talking about decoding. Then later, we'll be talking about execution. Just like we learn, think, and act. That's the beauty of computing. It reflects how the human mind truly works. Thank you.